The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
The electrolysis of molten sodium chloride. And typically, you're going to see electrolysis reactions in the other one we just did to demonstrate to you, but you'll see them in a single beaker, as we see here, right? Okay, wonderful. For the following reaction, we need to identify the anode, cathode, label half reactions, right? And we're going to demonstrate the electron flow. Great. Let's go ahead and label our anode and our cathode first. Well, for the anode is going to be the electrode with the positive sign, and that's where oxidation always happens at the anode. And then the cathode is going to be where reduction always takes place, and that's going to be at the anode. That's going to be at the negative electrode. Okay, great. Now we'll talk a little bit about our half reactions. Here, our oxidation state is +1 for sodium. Here it's -1. Here it's 0. Here it's 0. Now, reduction, like we said, it's always when the number is decreasing, right? So it goes from +1 to 0. Is it decreasing? Yes. This is going from -1 to 0. Is that decreasing? No. So here is our reduction reaction. Right, and here is our oxidation reaction. Wonderful. And reduction occurs at the cathode, oxidation occurs at the anode. Let's go ahead and fill that in. We'll begin here with our oxidation reaction of our two chlorine ions, right? That's going to give us our chlorine gas plus our 2 electrons. Now for our reduction reaction here, we're going to have 2 of our sodium ions, right, plus our 2 electrons, and that's going to give us liquid sodium, that should be there, liquid sodium metal. Just clean that 2 up a little bit. Wonderful. Okay, now let's talk a little bit about current flow. Wonderful. If you recall, we just said that electrons, they're always flowing from the anode to the cathode, right? Whether it's a galvanic cell or a electrolytic cell. And that's what we'll see as the following. Wonderful. That's supposed to be an electron there. We're just demonstrating electron flow. Okay, great. Wonderful. Now, what's powering this, right? Well, it's going to be the battery. The battery is acting like an electron pump, right? And what do we mean by that? What do we mean by it's acting like an electron pump? Well, what it's actually doing is it's pulling these electrons from this positive electrode, right? And it's pushing the electrons to this negative electrode. There we are. And this negative electrode, what actually ends up occurring is, because it's a negative electrode, it's going to attract, right? It's going to attract sodium ions, and the sodium ions with the electrons from the battery, right? It's going to react here to give us liquid sodium metal, and that's exactly what we would expect. Liquid sodium metal, as we see there. Wonderful. Okay, now in the same regard, to restock the electrons that were taken by the battery here, right? This positive electrode, right? What it's going to do is it's going to attract the That's a little messy. It's going to attract chlorine ions, right? And once the electrons are removed, we're going to see here that we're going to end up having chlorine gas, right? That the bubbles of chlorine gas are going to be produced at the anode electrode, the anode here. And that's exactly what we'd expect, because the oxidation here of chlorine, of the chlorine ion, produces chlorine gas as such. Okay, wonderful. Now, let's take a look at this reaction and see what would happen if we also had water present in here. Let's do that actually on the next slide. Oh, wonderful. Okay. So we see here, we'll pretend these values are not here just for a moment. Okay, we have the exact same setup, right, as we see here. Now, because we also have water in here, right, there's two possible reduction reactions that can take place at the cathode. Actually, one thing we should mention, remember, reduction always takes place at the cathode, oxidation takes place at the anode. Great. Now, there's two possible reactions that can happen at the cathode. It's either your sodium can be reduced or your water can be reduced. And how would you know which one is going to be reduced? Well, you can check from your standard reduction potential table. Now, if you go here, in a typical test format, you may be given a table similar to this one here, and you're going to have to be able to really extract that information yourself. So if we take a look at the reduction potentials, right? We're taking a look at the reduction potentials. The reduction potential here for sodium is such, and then the reduction potential for water is as follows. Now, nature will not do more work than it necessarily has to, right? By looking at these two reactions, right, which is the dominant reaction here, right? Which one would you believe? Well, it's going to be this one, right? Because why is it going to provide more voltage than it needs to? Wonderful. So if we go back and we take a look,